Hey guys, welcome to ANS Solver. Today we'll be doing the concept of product rule. Okay, so which is a subtopic in the chapter of differentiation. When do we use the product rule? You need to know that first. We use the product rule when we have a function multiplied by another function, f of x multiplied by g of x, and we are asked to find the gradient using the dy by dx. Okay, so basically the first function is u and the second function is v. Correct? Now, what you need to know is, okay, yeah, and another point, make sure that the variables which you have is same. Okay, so now the formula, okay, the formula which I have for the product rule is basically uv dash, okay, plus vu dash. So it's basically the u function multiplied by the differentiation of the v function plus the v function multiplied by the differentiation of the u function. Okay, so now we'll do some examples to get a strong hold of this concept. So let's say I have y which is equal to tan x, okay, multiplied by sin x. Correct? I have something like this, and we are asked to calculate the dy by dx. So I know here a function is multiplied by another function. So I take my first function as u. So I have that as tan x. I have my v, which is the second function, as sin x. Now I write my u dash, which is a differentiation of u. The differentiation of tan x is sec square x. Correct? And the differentiation of sin x is cos x. Correct? We did this in general differentiation. Okay, the differentiation of tan x and sin x. Now I have the formula which is uv dash plus vu dash. I know this is my dy by dx. So now I can simply substitute and write this as tan x first multiplied by cos x, correct, because I have uv dash, plus I have vu dash then, which is sec square x into sin x. So finally, this is my dy by dx. Correct? This is the equation for my dy by dx. In the same way, if I have, let's say, my y as e raised to 5x, okay, multiplied by sine 3x, and I need to calculate the dy by dx here. Correct? I know there's a function here multiplied to another function. So I'll use the product rule. So I take my u as the first function, which is e raised to 5x. I take my v as a second function, which is sine 3x. Now I simply take my u dash, which is a differentiation of, I'll write in the next line so that it's sure. Yeah. I get my u dash, which is a differentiation of e raised to 5x, where we'll use a chain rule. So first the differentiation of e is the same. So I write e raised to 5x multiplied by the differentiation of the inner bracket, which is 5. So I simply get 5 e raised to 5x. Now I have v dash. So here also I'll use the chain rule. So first the differentiation of sine, which is cos. So I'll write cos 3x multiplied by the differentiation of 3x, which is 3. So I can write this as 3 cos 3x. Now I can use my formula, which is uv dash plus vu dash. So u into v dash is e raised to 5x, okay, first, which is u, multiplied by 3 cos 3x plus vu dash, which is 5 e raised to 5x multiplied by sine 3x. Correct? This is basically my dy by dx. So now I can simply just write this as 3 e raised to 5x cos 3x plus 5 e raised to 5x sin 3x. Correct? Which is basically the final equation for my dy by dx. So the steps are pretty simple. So first you'll get an equation. Identify that there's a function multiplied by another function. Correct? See, the variables are same. Okay, then take the first function as u, the second function as v, differentiate it. Okay, get u dash v dash, use the formula, substitute and obtain an equation in in the terms of dy by dx. Correct? And then in past paper questions they give you an x value, so you can just plug it in the dy by dx and calculate your gradient. So now this was the basic concept. So let's do a past paper example. Okay, so this was basically from 2020 May-June paper 32. So curve has the equation y equals to cos x sin 2x. Okay, so I need to find the x coordinate of the stationary point. Okay, here you need to recall from AS level, stationary point basically means that your dy by dx is equal to 0 or your gradient is equal to 0. Okay, and in differentiation they use many terms, like let's say here we have stationary point, they use terms like normal, tangent, maximum, minimum. I know we've done this in AS, but what I've done is, if you see the last video of this chapter, it's basically key terms used in questions, so you can have a look at that. Okay, so there we have covered the list of key terms. Okay, and what does each key term mean? Okay, so it will be great benefit if you watch it. Okay, it will help you revise. Okay, so coming back to the question, we need to find the x coordinate of the stationary point in the interval where x lies between 0 and half pi, giving an answer to 3 significant figures. So here we have y equals to cos x sin 2x. Correct? As you can see, this is a function multiplied by another function. So let's discuss the approach first. What we can do is we can calculate the dy by dx first using the product rule. Correct? Then to calculate the x, we can equate the dy by dx to 0 and obtain the value of x. Simple. So first, for the dy by dx, we use the product rule, as a function is multiplied by another function. So I take my u basically as cos x, the first function, and I take my v basically as sin 2x. Correct? So now I have my u dash, which is the du by dx, which is the differentiation of cos x. The differentiation of cos x is really simple. Okay, minus sin x. Okay, we did this in general differentiation. And our v dash, which is basically the chain rule, will apply here. So first the differentiation of the outer bracket, which is sine, which is cos. So I write this as cos 2x multiplied by the differentiation of the inner bracket. So 2x differentiation is 2. So I can write this as 2 cos 2x. Now I know my dy by dx as the formula uv dash plus vu dash. So basic substitution, I can write this simply as first u, which is cos x, multiplied by v dash, which is 2 cos 2x, plus I have vu dash. Vu dash is basically sin 2x multiplied by minus sin x. Now what I can do is I can write this as 2 cos x cos 2x minus sin x sin 2x. Now I know this is my dy by dx. So to calculate x, we know it's a stationary point. So we equate the dy by dx to 0. Okay. Now to calculate x, Okay, you need to recall a little bit of trigonometry. Here you can see the cos double angle formula and the sine double angle formula, because you can simply use the double angle formula and write this as 2 cos x multiplied by, I know cos 2x can be written as 1 minus 2 sine square x, correct, minus I have sine x multiplied by, I know sine 2x can be written as 2 sine x cos x. So now I can simply write this as 0 equals to 2 cos x when I take 2 cos x inside the bracket minus 2 into 2, which is 4 sine square x cos x minus 2 sine square x cos x, correct. This is what I basically get. So here you may have a doubt, why did I use 1 minus 2 sine square x instead of 2 cos square x minus 1. Okay, so basically I wanted to get something common here. So sine square x, and I know sine x into sine x will give me sine square x. So I wanted something common. Okay, so you need to think like this, and then you should apply an appropriate formula. So that will only happen via practice, correct. So now let's go ahead. I have 0 equals to, I can write this as 2 cos x. I know I can write this as minus 4 minus 2, which is minus 6 sine square x cos x. I can take everything to the other side to get 6. Okay, I have 6 sine square x cos x minus 2 cos x, which is equal to 0. Here I can simply take 2 cos x common. So I have 3 sine square x minus 1, which is equal to 0. Correct? So I can simply write this as 2 cos x, which is equal to 0, and 3 sine square x minus 1 equals to 0. Now here I know I'll get basically cos x equals to 0. Let me split this. So here, as you can see, okay, I have the radian mode from 0 to half pi, the domain. So on the radian mode on the calci, okay, just do the cos inverse. Okay, simply do the cos inverse of 0, correct. When you do that, you get your answer basically as pi by 2. But here, if you see, x needs to be strictly less than half pi. That means this value of x is eliminated because it has to be less than pi by 2. So now I have the second possibility. So I can write this as 3 sine square x equals to 1. Then sine square x equals to 1 over 3. Correct? Now here I'll have sine x equals to the root of 1 over 3. Whenever there's a root, there's a plus or minus. Correct? Now I can write this as sine x equals to the positive root of 1 over 3, and sine x equals to the negative root of 1 over 3. Correct? So now I know, because my domain is basically from 0 to half pi, my answer is only in the first quadrant where everything is positive. So I basically know that the negative answer won't be possible. Okay, so now here I have sine x equals to the root of 1 over 3. So I can write this as x equals to the sine inverse of the root of 1 over 3. Now in the radian mode, make sure you're in the radian mode, shift mode 4. Okay, for the radian mode, to the sine inverse of the cube root of 1 over 3. When you do that, you basically get your answer as 0.615. Correct? You needed to give your answer to 3 significant figures. Correct here. So basically, Your final answer is 0.615. So you need to know how to eliminate, correct? Like why did I eliminate something like this? Okay, I'll explain it to you. Basically, you know, in ASTC, you have ASTC, you have 0, half pi, pi, correct? 3 over 2 pi and 2 pi. Here you know, yeah, that your domain is basically from 0 to half pi. Okay, and because from 0 to half pi everything is positive, that means sin x cannot be negative. Okay, it only has to be positive. That's why we straight away eliminated. And here we basically eliminated this value because it was not in the domain, correct? So the only answer I have is 0.615. So as you can see, you know, this concept of differentiation product rule is simple when one function is multiplied by another function, but you even need to be very strong with your trigonometry here. Okay, which I'd even mentioned in the trigonometry chapter, that it's a very important chapter. Okay, so even in, you know, the further videos where we'll do, you know, quotient rule, implicit differentiation, parametric, there also trigonometry will be needed because identities will be needed. Okay, and also the product rule will be needed, a very important subtopic. Okay, so now you can go to the next video, you can view the next video to learn quotient rule. Thank you for watching.